Howdy y'all. Today we're going to be talking about a nail clipper. This here is what our project is based off of. Nail clippers are typically used for clipping nails. Now that includes your fingernails and your toenails. Alright, so we have 5 components in this beautiful nail clipper. First we have our hinge, right there, and then we have these 2 clippers, the top clipper and our bottom clipper. Fourth, we have this pin that keeps all these handy dandy things together. And fifth, we have a pin that keeps our 2 clippers together.
So I'm going to talk to you about the sub-assemblies for our nail clipper. And I have our fishbone diagram pulled up, and there are 2 sub-assemblies. The first is the upper and lower clipper that are attached via a small pin. And our second assembly is the top lever and the rivet pin.
I'm Julia Kerr, and I'm going to show you how to assemble our nail clipper. So first, start out with our top and bottom clipper assembly, and I'm going to insert the pin, and then I'm going to clip the fulcrum of the top lever into the pin, and there's the assembled clipper.
Howdy. So all of our parts in our nail clipper are made out of stainless steel 316. Most of our parts were originally sheared and then stamped to make the complex geometry, and then ground down at the end to make sure that our nail clippers can still clip and are sharp. Our pin, however, was forged, and then the notch that is attached to the fulcrum was machined.
Hi, Randy Mays here with our updated clipper design. Our first upgrade is having a weld here instead of using a pin, which makes it stronger and easier to manufacture. Our second upgrade is having a clipper holder that goes right here and holds your nails in while you clip. Our third and fourth upgrades are on this lever here. We removed the complex geometry, making it simpler to manufacture, and made the fulcrum thicker so it's less likely to break.
Hi, I'm Owen Kyte. In order to gather some quantitative data on our product, we performed a Dfa analysis on both the old and improved design. The first sheet is from the original design. This sheet is from our new design. You can see that categories such as complexity and functionality, as well as error proofing, handling, insertion, and secondary operations in manufacturing were considered. Our design is less complex, more efficient, and easier to manufacture when compared to the original.
So these are 2 new updated pieces for our new nail clipper assembly. This first one is our nail catcher, and the second one is our top lever. And these were created using the SLA printer in the makerspace. And SLA printer is the stereolithography printer, which uses a liquid resin, which is then hardened via UV lasers. And it kind of gives us more of a durable part, which is what we really needed for our functional prototype compared to just a traditional 3D printer where the parts tend to be more brittle. So obviously these would be made using AISI 316 stainless steel if we were actually manufacturing them, and the nail catcher would be used via a blank and bend process, and the top lever would be manufactured using a shear and stamp process.